Hello everyone. Welcome to Integrated Circuit Technology Experiment number 5. So today's experiment is about study of diffusion processes using a TCAD lab from nanohub.org. So basically, the aim of the experiment is to study the two diffusion processes. One is the diffusion from an unlimited source, and other is diffusion from a limited source. So for both the above processes, we will be varying the temperature, time, and the duration of the process, and also the type of dopant. Okay, so we'll see the effect of each factor on the depth of diffusion and the diffusion profile, and at the end we will justify effect of each parameter on the depth of diffusion. Okay, now just a little bit of theory that diffusion is a process by which impurities are introduced into the selected regions of a semiconductor for purpose of altering its electronic properties. So basically, in terms of silicon technology, your diffusion allows the formation of source and drain region for a MOSFET, and it's also used for formation of active regions like collector base emitter in case of bipolar transistors. Okay, so with this background of theory, let's proceed ahead. So let us start with the procedure. So first is we have to go to nanohub.org, log in, and from the resources select a TCAD lab, right? So let's do that. So let me go to Google and type over here nanohub, and then nanohub.org we can click. From here we have to log in. So you must have already created your account prior to joining this lab, so you can log in with your Google account. So let me log in from my Gmail account. Okay, so now we are ready for the go to resources. And from here we will select tools. Now from tools you have to search a TCAD lab here. So select a TCAD lab and click on launch the tool. Okay, so once you have done that, you will get a window, and from these applications, now let's keep it open over here. Yeah. So from the applications, we have to select a process lab concentration dependent diffusion. So from here, we have to click over here and select concentration dependent diffusion process lab. So yeah, we click on this now. Okay, fine. So here you see various conditions, that is delta or infinite source. So from here you can select either delta source or infinite source. Delta will be limited source. Time you can change in minutes over here, right? Here you can change the temperature in degrees Celsius, bulk length in micrometer, concentration dependence, whether there is no dependence or there is C dependence. Then we can choose the dopant type. So right now it's chosen as phosphorus. So we can have all these parameters, I mean dopant types. Then also the dose, we can change the concentration also. Then in coefficient, we will keep it default. So for different materials, the coefficient are different. So accordingly, we can select, right? So yeah, so let's start with the lab procedure. So now First is we will be varying the temperature, variation of temperature. So that is step number 4 to 9. Okay. So let me keep the screen half open and as well as the procedure also open. So just looking at the procedure, you can complete this lab. Fine. So let me adjust the view size. Yeah. So let's start. So from the sub-menu conditions, select the infinite source. So first of all, we will select the infinite source. Okay. Then set time as 180 minutes. So we'll set this to, it's by default 120. So we set this to 180 minutes and then select the temperature as 900 degrees Celsius. So from here, we will go and select 900 degree Celsius. Select bulk length as zero point 0.8 micrometer. So we'll enter this value as 0.8 micrometer. Concentration dependence will be no dependence only. And we will select the dopant as phosphorus. Yeah, it is by default phosphorus only. P is the acronym for phosphorus over here. Okay, there are various choices, but we will select phosphorus for right now. And we will select the initial dopant concentration as 1 into 10 is to 20 per centimeter square. So it's already by default 1E20. That means 1 into 10 is to 20. Okay. And now we will press the simulation button. So once you press the simulation button, it will take roughly around, yeah, it's very quickly has shown the results. So after the successful simulation, you will get a graph of dopant concentration versus location. This is nothing but your bulk length. Okay, your bulk length is nothing but your x-axis. So let me show it to you in the full screen mode. Yeah. So this is what you get from infinite source. This is your diffusion profile versus the location or the bulk length, right? So you don't have to take any reading. You have to just take a print screen for this condition. Fine. So this is how the dopant concentration will keep on, varying. Now, let's go to the procedure again. So after doing that, instead of taking this print screen, let's wait. And yeah, so now in the tap condition, change only the temperature to 1000. Okay. Earlier it was 900. Now we change it to 1000. Fine. Keeping all other parameters same. And now we simulate it again. So what do we do is we have changed the temperature to 1000. Earlier it was 900 and we simulate with the new parameter again. So we have clicked on the simulation. It will roughly take 2 to 3 seconds to give the result. Okay, so the simulation results have come, and for 1000 degrees Celsius, this is the curve, right? So what we need to do is now again we change the temperature to 1100 degrees Celsius and we simulate again. Okay, so we'll make the changes over here. Instead of 1000, we will give 1100 degrees Celsius, and again we simulate with the new parameter. Yes, so we got this doping profile. Correct. Against the x-axis is my location in micrometer, or we can call it as a bulk length. Now what we need to do is, so we have what right now we have for different temperatures, we have the doping profile, infinite source doping profile. So below the graph there is a button all. So we need to press this button to see the previous two graphs will also be visible. Okay, so yeah, so let's do that. So we'll scroll down and we'll click on all. As you can see, the earlier profiles have also come, right? So earlier the temperature was 900. Here it is 900. Then we have 1000 degrees Celsius, and then we have 1100 degree Celsius, right? So yeah, so we can note that the earlier two graphs will be in light shade, and the current graph will be in dark shade. So we have to take this print screen for submission, correct? So yeah, so this print screen we have to take. So what is this showing us? This is showing us the diffusion profile for an infinite source for different temperatures. Okay, for a phosphorus dopant. Fine. So this print screen you have to take, and you have to add your roll number as well as your batch or your name, right? You can do this access settings, right? As been done, as been shown before. So yeah, that is mandatory to add your roll number and your name over here. Fine. So what this the diffusion profile is showing us that we have to interpret it and write it in the form of a conclusion, right? So this is your first graph, the first print screen we have to take. Okay, let's move ahead now. So once this is over, we have to clear all so that we can go for the next step. So once you clear all, the simulation profile will be disappearing. And yeah, so next part is variation of diffusion process time, okay, or a duration. So what you need to do is you need to set the time as all the parameters remaining the same as above. We have to set this to 120 minutes, and the temperature, how much we have to set? Temperature 1000 degrees Celsius. Rest all the parameters same as the previous step. So only these two changes we have to do, and we have to click on simulate. Yeah, so you're getting a diffusion profile. So right now, what next we have to do is, so we have to change the time now. So earlier the time was 120. Now you have to change it to 180, and then again simulate. All the process condition will be same. And again, for the third time, we have to change it to 240 minutes. So let's do that. So right now it is 120. We will make it 180 and simulate it again with this parameter, with this new time. Okay, so we are getting a new diffusion profile. Again, we have to do the same thing for 240 minutes. So for 240 minutes, we'll press the simulate again. Yeah. So we are getting the graph now. And here what we can do is do the same thing. We will have a totally three different doping profiles for different minutes. Okay, so let me take this as a full screen. And now I will go to view all. I mean, click on the all tab. So we will view all the plots for different times. As you can see, the light color plots are for the previous values, that is for 120 minutes, for 180 minutes, and the current one, which is dark red color, it's my 240 minutes. Okay, so this is the diffusion profile for an infinite source and for the phosphor doping. Okay, as a dopant. This print screen we have to take for the second case. Understanding? X-axis is my bulk length, or my, we can call it as a location in micrometer, and y-axis is the doping concentration in unit will be per centimeter cube. Okay, so right, it starts from 1 into 10 is to 20, and it drops down to this value over here, which is around 5 point. Let us see how much it is. Yeah, 5.94 into 10 is to 12. Yeah. Okay. So let us see the next part now. So again, this part is over. So we have to click on clear all. Okay. And now we will be ready with the third type, part C, changing the dopant type. Okay. So all the conditions remaining the same, only we will set the temperature to 1000 degrees Celsius. Fine. And we will simulate the graph. Okay. So let me keep the conditions as same. So for keeping the condition same, infinite source will be there. Then your time period will be 240. Yeah, they have given any time period over here? No. So we'll keep it by default as around 120 minutes. Okay. So we'll change to 120 minutes. And temperature is 1000 degrees Celsius. Rest all the conditions same. Only we have a phosphorus dopant now. So now we click on simulate. Yeah. So we click on simulate. We get a doping profile, but right now we have to change the dopant type. Okay. So yeah. So what we do is right now in the tab condition, we will change the dopant profile to arsenic, acronym as AS. So we'll go over here and select arsenic, and then we simulate it again. Okay. So while keeping all the parameters same, so this is the doping profile which we are getting for arsenic. Fine with it? So yeah. So what we need to do is we need to again click on the, let me just maximize, again click on the all tab so that both the doping profiles are visible. As you can see, light color doping profile is for phosphorus, and arsenic, we have this doping profile currently marked in dark red color. Okay. So you can notify this, you can add this details over here also, that this is the doping profile for the phosphorus, the light one, and the dark one is the doping profile for arsenic. So this again we have to take the print screen of it. Fine with this? Now let's go to the procedure again. So after doing this, we can clear all. So yeah, we can click on clear all so that we are back to this condition. Okay, fine. So yeah, so what we need to do is right now, let me just maximize this part. So after you complete all the steps, the variations were done for infinite source. Okay, this means that diffusion with unlimited source was there. So now what we have to do is now we have to repeat all the steps, that is variations case A, B, and C, by selecting delta source. Okay, delta source means diffusion with limited sources. So after you complete both the types of simulation, that is diffusion with infinite source and diffusion with delta source, then we will complete this lab. Yeah. So let's do that. Right now, only one change will be there. We will repeat steps number A, B, and C, but with the delta source now. So let's do that. So first of all, instead of infinite source, we have to select a delta source over here, right? Time we set it as around 180 minutes. Temperature will be around 900. So we'll put over here 900. We repeating the steps from step number A to B. So rest all is same, zero point 0.8, and here instead of arsenic, we'll select phosphorus dopant, and the dose will be around same. Initial dose is around 1 E 10 raised to 20. That is okay. So rest all the parameters remaining the same, and now we click on simulate. Yeah. So this is the doping profile which you are getting for a delta source. And now what we have to do is we have to change the temperature to 1000 and 1100. So yeah, let's start doing it. So right now it's 900. So we'll make it 1000. Simulate it again. So this is the doping profile for 1000 degrees Celsius. And next we'll make it 1100 and simulate it again. So you will get a new doping profile. Yeah. So here we are getting very, very small variation is there. So what we need to do is we need to click on all. Okay. So as you can see, the doping profile, it's varying. This is for 900. This is for 1100, and this is almost for like yeah, sorry, this is for 900, 1000, and 1100. Okay. So this simulation plot you have to take. Fine. So now let us go back to the case B now. So here we have to vary the time. So first we set first of all, we'll clear all the plots. Remember, we are in the delta source now. Okay, so we'll keep it at delta. Time we can keep it as around 120 initially. Temperature will be 1000. Let's consider it to be 1000 over here. And then rest all the parameters same. And we have to only simulate for different times. So again, go to simulate and click on it. It will show you the doping profile. Fine. And now we have to repeat this for 180 and 240 minutes. So let me take a full screen and let me change it to 180 and simulate it again. And then we will change it to 240 and again we will simulate 240 minutes and we'll simulate it again. So we got different doping profiles for the different time. Fine. We'll click on all to view the previous two plots also. As you can see, the doping profile is changing. The light color is for the previous ones. So this will be for 120 minutes, 180 minutes, and the dark red color is for the current time, which is 240 minutes. So again, we have to take this print screen. Fine. Now next, we will move on to the next part, wherein we have type of dopant. So over here, we'll take by default time. First of all, we'll clear out the simulation plots. So for this case, okay, let's click on clear all. For this case, let's take the time as 120. Temperature will be 1000. Source will be a delta source. Dopant type will be phosphorus. So let us simulate this. And for the next part, we will change the dopant type to arsenic, acronym as AS. And then we'll simulate it again. Yeah. So we got the two similar doping profiles for the arsenic and phosphorus. To view them together, click on all. As you can see, currently the earlier one, it is dark light red in color, which is the phosphorus, and the arsenic doping profile, as you can see over here. Okay. So again, I repeat, y-axis is the doping concentration per unit with the unit of per centimeter cube, and x-axis is the location or the bulk length. Okay, so this way you have to complete this lab, and let me just maximize this part. So we have completed the all the conditions with infinite source as well as delta source for case A, B, and C. Fine. So yeah, let me show it to you. So you have to add the waveforms, um, the doping profile from an unlimited source, that is infinite source. So you will get three different plots corresponding to variation of temperature, type, time, and the type of dopant. Okay, and you have to repeat it for the limited source, that is delta. Three different plots corresponding to variation of temperature, time, and dopant. Fine. And then you have to answer this post lab questions, correct, based on the observations or based on the trends shown in the graph, and you have to write a meaningful conclusion. So this will conclude the experiment. And yeah, if you have any doubt, you all can ask. Fine. Or else we have I mean, you all have completed this lab once you have six different plots. Again, I repeat, you have to do the variation for the infinite source and delta source for different time, different temperature, and different dopant type. Okay, so that is all for integrated circuit lab number 5, diffusion process.